Yesterday I made a video about this audio amplifier. I told about the quiescent current and how to test it, and well, I tested it with some automotive lamps at the output instead of the loudspeakers, and well, everything is visible in the video, and I will give the link to say all the things that I told yesterday. But now it's more in the definite stage, and I found, and it's very important, that when you use this audio amplifier not with the kind of zener substitute here with the transistor, and here you can set the quiescent current to a very low value, say 15 milliampere or so, but use it in this schematic that I also showed yesterday. And here you don't find that kind of fake zener between the bases of the two driver transistors, but only 3 diodes. It's important that with this circuit it only works properly on, say, approximately 30 volts. And yesterday I told it can work properly on 48 volt or 52 volts or whatever, but this circuit proved to work only, and not in the test situation with the sine wave generator and the square wave generator, but now in real with audio. And I have overdriven this amplifier with 20 kilohertz at, say, 1 volt here at the input, 1 volt AC at the input at 20 kilohertz, and it only worked in that case as when I used a 30 volt power supply. Otherwise it got too hot. So that's interesting to show. You can immediately see that test results often don't match exactly with the real situation where this circuit was made for. It's a guitar amplifier and an audio amplifier, of course, but it's especially a guitar amplifier, and a guitar amplifier must be able to endure a lot, and especially overdrive at the input. And that's what I tested today with music, etc, etc. So it's a good circuit, works properly, no problems at all. But with these 3 diodes here, you can only operate it on 30 volts DC. And that's good, because when you use a 24 volt transformer and use a bridge rectifier, the DC voltage is 0.4 times multiplied by the AC voltage. So then you have approximately 30 volts or 33 volts. So that's good. Let's focus again on this circuit. Well, here it is again. The transformer. I took out the old transformer that had a too high voltage, and this is a 24 volt transformer here. It can give out approximately 1.5 ampere or 2 ampere, and you can see here these big aluminum strips. They are, say, bolted to the core of the transformer to dissipate the heat inside this transformer. That's of course kind of not normal anyway. This transformer was, in my opinion, perhaps made for another purpose, so not for a real audio application. So that means that such a transformer can get a little bit hot or too hot, but you can be sure that when that transformer is made in a more or less proper way, and I think it is, it cannot burn out. Nowadays we have many modern, say, materials to make it possible that such a power supply transformer endures a lot of heat. Anyway, here are the kind of heat sinks. Quite warm, but for normal use, well, it's absolutely okay. And well, wanna show now some music, how this amplifier sounds. That's always very important, of course, how it sounds. Yesterday you saw on the oscilloscope that we had a kind of distortion when I sent in, say, a very high frequency of 20 kilohertz or so, and it was a square wave. You saw distortion into a kind of sawtooth wave, but anyway, that is one of the say properties of such a very simple setup that everyone can make and is very durable. Preamplifier is here. I can drive in here approximately 100 millivolts, so 0.1 volt AC audio signal. And well, let's listen. And important to tell, here you can set the amplification of the preamplifier, so you can overdrive the end amplifier, and that's good, especially for guitar, because sometimes with guitar amplifiers we need a kind of distorted sound. Anyway, I'm gonna move these two potentiometers to the front. That will be the next adaptation, so they will be here or so, or here, doesn't matter. Have to use shielded cable, absolutely sure. But anyway, let's listen. I cannot show real music. This is kind of, it's very good music to test an audio amplifier. But anyway, with real music you will of course hear kind of other sound character. And this amplifier is also published in my book Schematics to Audio Amplifiers and Loudspeaker Boxes, and it has 3, say, sound characteristics, and I will demonstrate it now. Three sound characteristics. You hear some, say, resonance out of the loudspeaker boxes. That's of course bad, but that has everything to do with the loudspeaker box that I use here. Typical old loudspeaker box of the 1970s. Has very good properties, by the way. So it can only handle 10 watt. Anyway, doesn't matter much. Of course it's very old, and perhaps the cones inside that box, in that loudspeaker cones, are a little bit sloppy, so you hear perhaps a kind of resonance. and you don't hear that here. This is a modern that's a modern loudspeaker out of the 1990s. So the cone doesn't resonate. It's a kind of bass box anyway. So with a very good loudspeaker, there's always necessary good loudspeakers to, well, give such an amplifier what it needs. The loudspeaker box is one of the most important things in an audio chain. So, well, listen to the other characters. That was all. So, I hope it was a little bit interesting. And, well, the transformer perhaps interesting to tell. The transformer, when you mount it directly on the chassis, there are a few problems. At first, the core, when the core is directly bolted to the chassis, you can get sometimes, not always, but sometimes a kind of ground loop. Very strange. I found it experimentally in the past. So when you want to mount a transformer, an audio transformer in an amplifier, mount it in an electrical way isolated from the metal enclosure, the metal box where you want to mount this in. And you can see here there's a kind of foam here, and I've used a kind of silicon cloth here. That's the next thing. A transformer can start to hum. When it hums too much, that's of course very boring, and that's the reason why you can mount this, for instance, with on a kind of rubber pad to keep the resonance from the transformer extremely low. And like I told earlier, these are the heat sinks of the transformer. But when you use a more expensive a more expensive transformer, that's no problem. The core will not get hot, or only a little bit warm or so anyway. And here you can see this is a kind of hood. Perhaps strange to see, completely isolated tin plate, and the hood covers the input of both the amplifiers to shield it and make the hum level, press the hum level down to the absolute zero. And that's very important. Hum is always, say, very irritating. When you have a good amplifier, there must be no hum, absolutely no hum. So 1 point earth and 1 point shielding, that's important. There are many videos on my YouTube channel about that issue. And this is the hood that covers the input and shields it from hum. Well, that was all.